we are live, guys. Good morning, good day, good evening, wherever you are. Let's kick this stream off. Ton of cool work to be done today. Let me open the Open NLLB channel. Join this channel if you haven't already. If you're curious about the project, that's where the collaboration is happening. Let me quickly share the stream as usually. And here's the stream link. So what I'll be doing now is we are analyzing the HBS data, figuring out how to split Bosnian and Serbian into Cyrillic versus Latin, etc. That's the plan for today, guys. Hope you're all doing well. I encourage you to engage in the chat as yesterday we had this person here, Creative Self. I unfortunately don't know his name, but he was writing code as we were doing the stream and helping out. So he wrote a couple of very cool scripts for like chunking, something I've done in Python that was maybe a bit more readable, but way slower for the amount of data we had. So this actually worked very nicely. So yeah, let me see what's happening here as well. Okay, somebody created a space on Hugging Face that you can explore the results. That's amazing. Awesome. I'll check it out a bit later as well. Let's focus on today's tasks. So first, let me see. Maybe we can submit the Opus download script first, and any other changes I haven't pushed out yet, and then we can start analyzing our data. That's kind of the next step. This is some technical debt I have to kind of attend to, and then we can go here and analyze the data, visualize the data, figure out how to classify between Serbian, Cyrillic, and Latin, and same for Bosnian. I'm not sure whether we can just do it using Unicode code points, but that's TBD. Let me open up the VS Code. It's day 22, by the way. 22 days of working on this every single day. The progress has been enormous. Let me just close everything here. Okay, and let me open up, download Opus script. Let's also navigate to this location. Maybe let's go to the root actually. See what we have as the new changes. So let me see what we have. Clean Opus zip. I won't be submitting this one because or maybe, we'll see. It's under data. And then other than that, we have analyze data, length, code mappings. So everything under data basically can potentially be submitted, and then the download script as well. So download and clean, analyze and learn code mapping. So let's see. Let's see what changes we've got here. Okay, I added couple new languages and this mapping. This is fine. We can just commit this as it is. And then analyze data. I think that was just temporary hack I added here to just figure out some details, number of lines, so we can actually revert back the changes here. That's what I'm gonna do here. I'm gonna revert back the changes for the analyze data script. And we'll be using that script, by the way, right now. So check out the analyze data. Yeah, and then we're left with, we can add blank code mappings without any edits as it is. And then we have the download script and the and the cleaning script. Okay, let's see this one. Okay, so I don't think we need this. This was just some temporary function I made to analyze the local HTML. Let me see what's the best way how to proceed here. It's currently fairly specialized, and you would have to download the Opus tools if you want to get it to work. So let me see the install instructions. Where did I specify that? I think we have requirements. Opus tools, I can add it here. Let me just check if we do conda activate pip list. Do we have, if I grab Opus tools, okay, I think we can just have it like this. It should work. Let me add that immediately. Oops, git status, git add. Let's add the requirements. And we might need beautiful soup as well. Well, only if you want to use this code here. So let's maybe add it inside here. Let me refactor this a bit. I always try to have standard library functions here, and then imports, and then or third-party pip packages, and then finally local imports. So download the HTML source. Let me think for a second. If we just open up Opus like this, inspect source. Yeah, we can't really just ping an API. Okay, download the download the HTML source from the Opus website for analysis here. We can just scrape from a URL because it doesn't change. When we specify the language direction. Okay. Then we load, then we parse, grab the tables, go through the tables, and our target table as a string in the header, and then we go through the table rows, keep in the table header, oops, so grab the first cell from the row as it contains corporate name, and then that's it. Note some of the corpora names are not even displayed on the website. For example, Ubuntu or Croatian, Serbian, and Bosnian can be seen on the website, but the Opus tool can fetch it. Okay. Next up, this one is not even used. Okay, then you specify some stuff here. And then getter, get the corporal list. This will mostly do the job. Let me just, I need to clean it up a bit, of course. Hello, Smith, welcome. Let me just make it somewhat pleasant to work with. I'm gonna do it like this. I'm gonna add a main file as well, just to make this a bit nicer. Okay, and then I'm doing well. How are you doing? Just trying to push through here and get some progress. Script to download Opus data. Okay. We can specify all of this down there. And then download data from Opus. Define the function like this, and then just wrap all of this, indent all of this. Okay, looking good. So now we want to call this one, and we'll want to pass the arguments. So I'm going to call the function here and then just pass the args. I am traveling, but it's gonna be on Saturday, so like I have a couple more days left. Thanks for asking. Let me see. So we want to specify source language, and let me think for a second. Okay, currently I'm gonna support only a single language direction, so let's do it like this. So we'll have something like this. Source lang. Maybe like that, and then required. It's not required because I'm gonna set default. I'm just gonna put default. If you don't want to change it, you don't have to. Default is gonna be English. And then similarly, copy paste this one and just change this to target language. T, that's gonna be, let's say, Serbian. It's gonna be the target language. And then that means we can just delete this, and then root, specify the directory. We can delete this, and we can just have this one. Now let me create in the launch JSON, find the download data script, download primary data. Okay, we can also have something like Opus download, and we'll have that directory. Specify directory, It's gonna be like a prefix. Let's say opus. Like this. Looking good. And then what we can do is inside of opus, we can actually create those two directories. Like the root one is gonna be, let me think for a second. Hold my motion. Thanks, man. Memes, man. We thrive on memes. Okay, directory. So download and okay, I'm gonna just specify all of this here. So we parse the arguments and then we grab the. Now I'll have to do this. Let me see. Root directory. Is gonna be like this. And we just say root directory. And then we just call os make directory. This is okay. And then we pass in the arguments. And then in there, we'll have the source lang. Okay, we'll have the source lang be equal to args source lang, and then target lang this, and then we just specify it here, and then we specify it here, and I'm gonna make sure that people pass in the right format. So let's grab the source lang. Let's grab the target lang. Assert that the length of source lang is 2. Opus expects 2 letter codes, but got this. Same here for the target, exactly. And then we just pass in, oops. And then we just pass in the arguments. Okay, this looks good. This is the corporal list. Then we can maybe create like allow and ignore lists for different languages. Maybe let's do something like import from collections, import default dictionary. Let's create like ignore corporal list. It's gonna be default dictionary of lists. And then for different languages, we're gonna add what are the forbidden ones. I'm gonna make this a function. map to lowercase. Okay, just go for the elements in the value, just make them lowercase. Okay, that's it, and then we return back exactly. That's gonna be the ignore corporal lists function. Okay, and then what else do we want? You can also download a particular corpora. Let me see how we can do this. I'm gonna save these nodes somewhere here. Opus notes. Indent this back here. Let's just have it saved there as well. Okay, now let's get back to VS Code. Let me see what's the best way to do this. What's the best way to do this? Convert this to lowercase so that we don't have to do lower here. And then ignore list is just gonna be extracted. Ignore list is just this from source and target languages. Let's say that's decent. And then we can use that ignore list. Here, we don't have to have hundreds of these. So if corpus is in ignore list, we just ignore it. We skipping the corpus for these languages. That's fine. Otherwise, we do this. We can also do it like this if we want to unify all of this. So we can do something like skipping if it's an ignore. Otherwise this. And then if corpus is ignore, then we continue. Whoops. And then we just delete everything else. So do this and then skipping if corpus will this work? Else this. So counter and then skipping or nothing. Ignore, we ignore. That's it. We don't have a loop here. And And we also want to fix the allow list. Let's lowercase it. We can delete all of this. And then let me see what else here. So we don't need this. We just need to ask if corpus is not in allow list. We continue. Otherwise, map to the right location, map to the right code. So we go from 6391 to BCP47, source language in ISO 6391 format, and same here. Okay. For your bookshop, because of bad alignment file, we have to manually download the most format from the website. Okay, I'm gonna put these nodes somewhere here. And then let's see. So we want to save now to this particular root folder. So root folder is going to be the root directory. Root directory looks like this. And then we specify corpus and then the code. We save there these files, and then if it does not exist and caching is enabled, I'm gonna, let's see, use caching, and then I'm just gonna add this as a boolean down below. Let me quickly see whether I've added a boolean here somewhere. Store. I know I have these flags somewhere. Arc parse. I don't know. I've never used Rust, honestly. Literally never in my life. So I have zero information on Rust. I did see that there are some trending projects in Rust on GitHub. That's all. Let's see if I have bool. Okay, get a bool flag. Aha. Full flag arc parse. Okay, something like this. Maybe like that, and then action, and then help. If set with caching enabled, if the output files already exist, we skip download and process step for that purpose. Okay, and then if caching is set, wait. How did I end up here? Oh my god. Wrong file. Here we are. And then just move this here. Whoops. Nice. Let me now just fix this. Okay. That's it. Use the caching. So if use caching and if you're using caching, actually, if we're not using caching, so if it's false, we want to always go through. Let me see what's the Boolean expression that we need here. Just a second. Pretty interesting spacing, really fast. Nice. Did you try Mojo? Let me think for a second. So if we're not using caching, if that's false, then no matter what happens, we want to proceed. But if we are using caching, in that case, or if using caching and these conditions are true, this does not exist, or this one does not exist. In that case, we go ahead as well. Okay, I think that's the right condition. Whoops. So, oh my god, I hate when this opens. So what do we do now? We grab the languages, we grab the output files and download the directory. Where are we going to download the data to? print pairs, extract. Let's just create a reasonable location there. Let's just create a reasonable location. Root directory. We write the bad corporal list. For the source lang to target lang. That looks good. And finally, we have to figure out where to download. The download can just be coupled with the root. So download can be, this is the root directory. And if we're saving inside of a corpora there, the download can also be like Opus download. I think this is good enough for now. Okay, this should work. Let's quickly test it. Make sure it's not broken before I commit it. And then we continue on to the other work. Okay. Dum, 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 dum. Dum, 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 dum. Okay. Not there. We want to just focus on add the directory here, call it temporary, and then copy the path, and then go here and set the Opus download like this, and then come here, specify the Opus download, and run the script. Let's see whether it all works. Okay. Root directory, data tmp, assert, start the download. Whoops. Aha. Forgot to add the corporal list. The corporal list is if you want to specify any particular, see where this is specified anywhere. Narcs type plus, something like this. Okay. Go back here. Specify the corporal list. Corporal list. Default is gonna be I don't know, the default. I'll just say all. Okay. Stop this. Allow list is set to all. If it's not there, okay, so that means the following. If I'm gonna do it here then. Allow list specified here. Okay, if length of allow list equals 1 and it equals all, in that case we grab all. That's it. That's it. This should now work. We've set it to all, so let's continue. Let's resume the run. See whether it now works. Kick it off. Get the corpora. 25. For Serbian, I think that was the right number, right? If we go up here to dos, Serbian data, we had 25 exactly. Okay, then we continue. Corporal list is set to all, and then we just set it to everything because it's set to all. Get ignore. For Serbian, we ignore. This is bad. This is bad because we want to specify what we want to specify. Target language, let's say. I mean, I'm making some assumptions here, obviously. Target language, and then just retrieve back for target language. No, wait. This was bad. We just retrieve the whole thing, and then here we do it like this. That's fine. Key error English. Well, I mean, it's set as a default dict, right? That's why I've said it. It's a default dictionary. And okay, let's maybe just set it for the target language. Let me resume here. I'm gonna remove the breakpoints, kick off the run again. And here are the ignore data sets. Let's see whether those are all that we need to ignore. For Bosnian, open subtitles and NLLB. So for Bosnian, these two. For Serbian and Croatian, let's see. For Serbian, SR code, Serbian. We want to ignore NLB, CC matrix, and open subtitles. And I think that's what we're doing. NLB, open subtitles, and CC matrix. For Croatian, let's find the HR. I think that's a reasonable approach, Smith. Like, you don't have to try all of the latest stuff. It's still not, unless you know why, or you just want to have fun. HR Croatian. So let's see which ones. Okay. Even CC aligned, I think. Nah, I think these three are fine. We're just gonna ignore these three. The reason we have ignore lists is Opus tool doesn't work well for bigger data sets, hence adding ignore lists, empty ignore lists. Yes. Sounds good. Final run. Map. Inside of the TMP folder, we have the data set, and we go and we save it. Here it is. Kick it off again. And here is what we end up with. We download here, we have the data here. Okay, let's see if it's as expected. And it is. That's it. Let's do one more. Let's do one more. just to make sure it's working. Skipping the CC matrix because we're dealing with Serbian and CC matrix is ignored. Okay. Third one. Did we download it? Oh, why wasn't this one processed? Wait. Something is not all right here. What's the set of bad corpora? Both of these are bad for some reason. Wait, why? Something is off here. Wait. If it's in the ignore list, we should skip it. Why did you even create the directory? Something went wrong. Wait. We have some mess up. Let me delete this, and let me delete this. Rerun. Okay. The first one we are processing. Okay, the next one, CC aligned. Aha. Well, allow list is kind of this, I guess, minus. Can we do minus? I don't think we can. Okay, something like that looks better. So if it's not in the ignore list, if corpus not in the ignore list, then we add it here. Resume. And when do we want to create? Let's imagine. Okay. Kick it up again. Okay, I referenced it before adding it here. Rookier. Processing CC aligned. Yes, okay, let's go and process it. What can go wrong here? Oh, that can go wrong. I can't just rename, I can't do this. So what I have to do is, if corpus should be good now. Couple of bugs we have to iron out. I messed up because the Opus read expects actual name without messing up the capitalization of the letters. So Okay, we're just skipping stuff because not in allow list. What is going on? Just a second. We have the ignore list. We have the allow list. Allow list is gonna be lowercase. This should also be lowercase. And this should be lowercase, so we end up with allow list, and then when we go to the corpora list, if it's not in the allow list, we continue, but if it's in ignore, we also continue. Well, we can just do it like this. Might as well condense them. It will be easier to understand why this is failing. Okay, Bible is allowed. And then a ton of these are not allowed. Why? Okay, let's just continue, guys. This is just there is some annoying pesky little bug here. Okay, Bible is allowed. Cool. Let's continue. And then corpus CC aligned. What does corpus lower give us? Is this okay? Awesome, Smith. See you later, man. Good luck with the errands, and catch you a bit later. So that's the ignore. Let's the allow. Why the heck? Wait, allow list. Okay, okay, I get it now. I'm stupid. Rerun. Okay, I'm gonna stop here as well. This looks like it's not working. Awesome, that would be amazing, man. Really looking forward to your contributions. I'll be flying to China, so that period might be a bit lower for me, but I'm gonna try really my best to just keep the project in decent shape for those 7 to 10 days I'm in China. But then after I'm back, I'm gonna make a new streak. Like my goal is to connect like every single day for like 3 months at least. That's the goal. I think I'll manage it after China. I don't have any trips upcoming, so it's gonna be just relentless focus on this project. So like I think it's a great project to contribute to, just because I'll be constantly here and helping out. Awesome. See you soon, man. Have a nice day. Download Opus. Whoops. Git add the file and just add the Y here. Happy weekend as well, man. Catch you around. Clean Opus. Download the text, clean the Opus zip. Should I actually add this? This kind of works. Kinda. Fix encoding issues. Okay. This is kind of experimental. Hey, Sir Catreo. Thank you. Thanks a lot. How did you find the stream, by the way? I keep asking people just to have a better understanding of how people stumble across these. Is it just like notification on YouTube, or you found it in the feed, or LinkedIn, or whatnot? Okay, let me add this one as well. And we can commit. Commit. Add opus, download, and cleaning scripts. Push to origin. No worries. Welcome to the live stream. Okay. We are ready. That was the first task. Just kind of submit everything we had done over the last couple of days with those download scripts. And now let's run some analysis on the data we have. Okay. Let me delete this temporary directory. By the way, if you are not familiar with what we are doing, join the Open NLLB channel. Check out what's going on there and check out the pinned posts. I should have mapped the roadmap as well. Let me see whether I mentioned roadmap. Roadmap. I should have mentioned the roadmap somewhere. Okay, let me pin this one. Now you have everything you need to get some familiarity with the project, but we are initially replicating a No Language Left Behind project, which is a machine translation project for 202 languages. Okay, find the analyze data script. I now want to analyze, let's see what we want to analyze. Lengths of sentences, just to understand whether there are any serious issues. And then, so line lengths and number of sentences. Those are the two ones we want to analyze now. The duplication, I'm gonna just run that through the filtering stage. We won't be doing it here. So feature type line length and number of sentences. For the languages, we won't specify it. So I'm just going to specify the dataset root, which is going to be initially Serbian. Copy the path, go to the launch JSON, go to the analyze data, specify the location, and I think that's it. That's all we need to do, and now we can just run it. It's not gzip, verbose. Did we set the verbose mode? Yes, we did. Verbose mode, and then this. Okay, looking good. Let's analyze the data. Let's see if this just works. If I just kick it off with the right config, if I run it, do I have to babysit it? Will it fail? Okay, there's some outliers. Okay, maybe the verbose was a bad idea. Verbose. If it's verbose, it's basically gonna paste the outliers. There's a ton of outliers. I have to stop this just to remove this and then rerun again the analyzed data. Here we're making progress. Apparently 50, why do we have 53 files? Let's see. Okay, fair enough. Why is this not a language file? Oh no, oh no, oh no, I see issues already. So Serbian can be both Latin and... Okay, we'll have to do some modifications here, just a second. Let me see what's the best way to do this. First of all, let me just clear a bit the Serbian corpus here. I have a ton of data that we don't need anymore. So this Makoku, I downloaded it manually. There is then the parse Makoku dataset. Why didn't we specify this? I'm gonna move this. Cut, paste here, parse Makoku. I forgot to submit this one. Corpus name, source language, input file paths. There is the opus, there is the Makoku, and there is the download NLLB. Download NLLB, download opus. Download NLLB mind. Some renaming there. clean, analyze. Parse Makoku. Do one. Manually download from Makoku dataset. Download desired data from Makoku website. Like this. This is the dataset. This is the website. Step 2. Modify the paths below to point. Run the script. Okay, because I don't want to waste any more time doing these silly refactorings. We have to move fast. Chunk. Temporary. Okay, there is this temporary file for chunking. There are gonna be some data utils. Paste this one here. Files into shards so that we can subsequently manually go through the data in, for example, VS Code. Delete this one. Looking good. Okay, that's it. I don't think we have anything else to change. We'll have to do some refactoring later, but like I'm a single person doing all of this. I have to kind of cut some corners, keeping some decent quality as much as I can. There's one thing I'm worried about. Let me see here for the data sets. Okay, GNOME worked. We have a ton of data here. Ubuntu. Did I mess up Ubuntu? 37K. Let me just check something on the Opus website. For Serbian, Ubuntu is not even available here, so I can't do it. Okay. I don't think I messed up anything. That's good. Analyze the data. Okay, I have to change a couple of things. For Serbian, we are supporting both the Latin and the Cyrillic script. So I have to modify the line code mappings for Serbian, and I have to add multiple mappings. So let's see, ambiguous codes, this one, it has 2. So we have to do the same for Serbian. We have Serbian Latin and we have Serbian Cyrillic, which means that makes Serbian ambiguous. Which Serbian? And same for Bosnian. Which Bosnian? Are we talking about Bosnian Latin or Bosnian Cyrillic? Having said that, will this now work, or I have to do some additional changes? Let's see. Run. We'll have to modify this to 204 because now we support 2 new scripts. Rerun. Any other issues? Serbian Latin, not a language file. Why are you complaining? Because this one here, unsupported language codes, are which ones? Okay, we are not in that category, so we get filtered out somewhere else. Extended. Are you in the extended? Okay, so here we are doing what? Opening up the extended lengths and adding to this list Serbian Latin and Bosnian Cyrillic. Let's try again. Okay, that worked. Now retrieve, assert, and do its thing. Let's just remove the breakpoint, let it run. For the language code, yeah, for the length factors, I'll have to modify that as well. Length factors in Stopes needs to be quickly augmented. So length factors YAML Serbian. We just add the same thing for Latin and Bosnian. Cyrillic. I'm gonna just assume they have the same number of letters, which is not completely true. Cyrillic is usually more concise. But for now, that's a good approximation. Go back to analyze. That's all because we are supporting 2 new scripts. All of these issues. Okay, so let's see what's the output now. Analyzing data, found 54 languages. Why 54? Why 54? Aha. Okay, because we have 25 plus 2 in Makaku. I guess that's the reason why. If we open up the Makoku, we have 2 here. Okay, almost done. Almost done. 46 of 54. We went through the biggest. Open subtitles is one of the biggest ones. We went through the NLLB. Almost done. Here we are. On 2 languages. And apparently 200 million sentences. Oh my god. That's a lot. And they said here we have 100 million. So what's up with that? Oh, I guess 106 it says there, and we got 209. Divide that by 2, I guess. I'm not sure how we are counting. Are we counting both files? Let me just see. Sentences. Number of sentences. For English, Latin. Yes, we are counting in English as well. And then Cyrillic has much more data. Well, Cyrillic, quote unquote. We can ignore this for now because I'm messing up Cyrillic with Latin. I'm currently combining them together. Okay, let's see the line length, guys. The max ones are, some are very, very long. There are some outliers. Let's see how many. Let's see how many are outliers. Half a million sentences, which is a small percentage. And let's plot the histogram. And this is for English. This is for English. Yeah, not really useful because of the outliers. Let's continue to the second language, Serbian Latin. Why are you not showing me the data here? It's a bit slower. Okay, this is glitching. My whole VS Code is glitching because we're dealing with a lot of data, so it's a bit slower. Come on. It failed. Literally failed. Okay, before plotting, I'm going to remove the outliers. Histogram of line lengths. Logical end. If you're smaller than the upper and bigger than the lower, then you can constitute non-outlier. Non-outlier line lengths, and then just plot it here, and we should be good. Why did it fail though? Okay, because I tried to plot all of this. Fair enough. Let's kick it off again. We're going to split the Serbian data into Cyrillic and Latin. I just have to understand how we can do that. Crunching the numbers in the background. And we are done. Line length dictionary. Okay, F10 is again not working. Okay, it actually did not fail, it's just very, 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 very slow, painfully slow. Do we need to shard it? It's still running, doing something, but not really moving. Took 30 seconds to do the representation. Why are you even doing that? I just asked for keys. It's not that big of a... It's like 100 million integers. Come on, that's not a lot. That's like, what, 400 million bytes? 400 megabytes, what? Oh my god. Line lengths. Compute. Get the sum. Okay. Plot the histogram of the non-outliers. So for the non-outliers, it looks like this. Fairly smooth distribution with a peak around here. This is unfortunately not an interactive plot, so it's not the best one in the world, but it gives us some understanding. Okay, hit run again. Whoops. Serbian Latin. Number of outliers. Still small, relatively speaking. Plot. Plot looks very similar to English. Okay, do we have any other data? No, we don't. Let me think for a second. Languages is set to none, in which case we should always enter here. Compute line lengths for language code. Why don't we have results for Serbian Latin? Cyrillic. We have English Latin. What are the keys here? Why only those keys? What's up with Serbian Latin? Okay. Huh. I'm not sure why we are not getting Latin here. Would be fun to find some big outliers. So I'm gonna enable the verbose mode. I'm gonna enable the verbose mode now. Go back to analyze. Increase this such that if it's not in this region, then show me the data. What were the outliers for Serbian? (15, 16, 16, 17, 23, 22, 70). Okay, let's put it to 15K. And let's run this. Found the outlier. Run the analyze data. And also would love to understand why are we missing Serbian Cyrillic? This will be showing me some very, very short sentences. So we have to put this to 0 and rerun. We don't want to see the short ones. We just care about the long sentences. I have to put a breakpoint, rerun. Okay. Line 58127. 58127. Okay. Fair enough. This is a clear outlier. Let's go. Nine 7 681. Okay, same here. Let's go. Line length 17, same file. 196515. This looks like some Wikipedia stuff. Okay. Run again. Again, Wiki matrix. 315840. Okay, again, just some list. We can actually filter out all of these without any issue. And then 3505491. Same here. Run. Five 11699. Okay. Let's continue. Line outlier with length 16871. We should push for longer context length, by the way. We should use some of the work that Yarn folks have done to train these models. We do need better data for that though. 591691. Okay, again, some list. Run. mostly in Wiki matrix, all of these outliers. 619473. Seven four one two three five. Eight five five 763. All of them are just lists. 865 209 or Wikipedia chemistry stuff. 8741 oops. 874144. Same here. Run. 42508. This is not now just English. We can just continue here. Okay, no more outliers apparently. It seems most of them are in the Wiki matrix, if not all of them. Most length outliers are in Wiki matrix, as could be expected. I would also expect some in CC matrix or in NLLB, but let's see. It's running. Why is it so slow for CC matrix? What's going on? Looks like it's stuck. Okay, something is not okay here with CC matrix. The last time we were running this went by fairly fast. Now it's stuck. No idea why. I'm gonna stop the program if it doesn't progress over the next 20 seconds. Not sure what's going on. Poke it with a stick. Come on, move. We run. analyzing sentence lengths. In the first file, and then in the second one. While that is running, let me just see what else are we computing here. So we are computing number of lines. Okay, we've seen some of the outliers. And language direction. And then we're computing line lengths, so we can ignore the dedupe. Line lengths for the file, and then for the direction as well. Number of lines and line lengths. Why is this stuck? How big is the CC matrix compared to some other ones? Maybe that's the reason. For Serbian, CC matrix might be one of the biggest ones. 26 million, but that's still not an excuse. It should run fairly fast. Okay, let's for the second just ignore the line lengths and just compute the number of sentences, because I was confused. Why are we not hitting different scripts for Serbian? We're just hitting the Latin one, although I have both Cyrillic as well as Latin. So this is Latin and Serbian Latin. Fair enough. Some will be Cyrillic, some will be Latin. This one comes from XLN, which has English, Latin, and Serbian Cyrillic. Okay, and then that means you're messing up something here. Let's see what. For some reason, this is set to Cyrillic, yet this is set to Latin. Wait, I equals what? 0, 1. So we grab the file and then the Serbian. I completely don't understand what's going on here. I plus 1 should just give me this, and if I grab 0, if I grab 1, I should get Serbian, not this language code here. Aha, because we mapped it here. And we're always mapping it. Okay. For now, it's fine. So for now, we're just mapping everything to Serbian Latin, even if it's Cyrillic. No matter what it is, we retrieve Serbian and we always map to Latin. Okay. So 106 million. We have 106 million sentences from Opus plus Makoku for Serbian. That's the order. And that's the amount of data we're roughly dealing with. Let's see for Bosnian. For Bosnian, we need to change the launch JSON and just set it to Bosnian and rerun the analyze data script. Rerun this. NLLB has a ton of data for Bosnian. The bulk of data is in NLLB. So we found two languages, which is the Latin and the Cyrillic script. We found that many sentences, two language directions. Again, Bosnian, Latin, and Cyrillic. For this direction, we have 94 million. And then 100K. So 95 million. I think that's roughly what Opus told us as well. So if we go to Bosnian, BES, 95.6 million. That's roughly what we observe here as well. So we are good there. And finally, let's try the Croatian. Croatian is going to be HR. Stop this. Run analyze. Rerun analyze data. I think Croatian has even more data. Let's just see. And definitely many more files, many more data sets, although many of them are very small. So let's see how that goes. So let's see, we have two languages. I guess English and Croatian, okay, yes. And then they have what, 99 million, a bit less actually than Serbian, which is expected given that Serbia has more speakers, but unexpected given that they have more data sets. Let's see, HR. Croatian, the number reported here is 112 million is reported. But we had some discrepancies, right? If we open up our analysis, we go to Croatian. I remember there were some big discrepancies for some of the data sets. 2 million here. And then we lost around 10 million here. Over 10 million here. So that explains, I think this one explains it. This is around 11, no, well, wait, see, this is like over 12 million that we lost. 12.5, roughly 12.5 mil here, and then 0.2 here. So that's like 12.7. So if we subtract that from the expectation here, 12.7, we expect around 100, which we saw. We got around 99. That's it. So we have a fairly balanced distribution across Bosnian and Croatian and Serbian. Croatian, $99 mil. Serbian, 106 mil. And then Bosnian was around 96 mil. Let me see up here. I remember we had the same numbers. So yes, around 96 for Bosnian. Okay. Let's see whether there is any insights when it comes to line lengths. And I think that's the first analysis that we'll do here. feature type. Let's do the line lengths. Again, this is for language creation. Reduce this back to 1050 and this to 5. And don't put the breakpoint here. And don't put verbose. Remove the verbose. And now let's just kick it off. Analyze the data. Just some quick numbers to understand the number of outliers, whether there is anything really messed up. We might want to fine-tune these line length thresholds for our languages, for HBS languages. Okay, we are processing CCLine, which is one of the biggest ones. CCLine had a ton of porn, very low quality data, a lot of noise, many short sentences. NLLB was higher quality. CCLine was definitely the worst. Okay, we're counting the number of lines and the line lengths. Let's see how many outliers we have in Croatian. I guess we should specify those thresholds depending on the tokenizer behavior. Let's go. Grab the line lengths. Max 22,000, 40, 46, 30. Okay. Number of outliers. 400,000 sentences are outliers. It's a very small percentage of the whole data. We plot it. Okay, nothing super insightful here. Oops. Looks very similar to the interesting parts are, why do we have these very nicely spread out spikes? On the x-axis we have the line length, and on the y-axis is the count by number of sentences with that particular line length. I noticed this is for Croatian, but I've seen the same plots for Serbian as well. Any hypothesis? That's interesting. I think is this English or no? This is actually Snap, that was English. Let me see whether there is any difference here for Croatian. Okay, a bit more outliers for Croatian. And the plot, I think it will look the same. Yes. It's the same thing. So yeah, we can ignore it. Okay, so why is that happening? I don't know. Would be fun to understand. We can maybe filter. We can find the thresholds and then filter out those pieces of data to understand it. Would be fun to also understand the number of duplicates. Let's see for Bosnian. So let's put yes here and rerun. Run again, analyze data. I'm gonna put this as a good first task, by the way. I'm gonna go here, go to the Open NLLB, create an issue. Let's see whether we have the same conclusion here. Probably it's going to be the same thing, just because all these data sets are correlated. Yes. Regularly spaced out histogram spikes for HBS languages. See below. Let me think for a second. I don't want to confuse them. I'm just going to say in characters. instructions download the opus and koku data using the scripts, using the download opus. Using the download opus script. Okay, once you download the data, you need to use this script parse makoku. We're not using a custom pipeline, we're just using Hugging Face. Download opus. Okay. So depending on how fast are people to pick it up, I might do it myself, or because it will take some time for people to download the data and do everything. Let me think for a second. What else? We now know how many lines roughly we have for these language directions. We've seen what's the rough trend with the line lengths. There doesn't seem to be any unhealthy number of outliers when it comes to line length. It's usually some very small percentage of the actual data. We might be filtering out some good sentences as well. I'm thinking what's the best way to do here. We need to understand if we take a sentence that has 1050 characters, what does that translate to when we tokenize that using SPM 200? And if that's below 512, then we're good. We just need to see how that translates to the actual context length. That's one thing we have to understand before we specify the actual filtering. So or should we train our own tokenizer? I don't think for now we should do that. But then again, we're wasting we're introducing a ton of complexity by using the SPM 200. Okay, those are some thoughts I have now. Next thing I would love to do is split into Cyrillic and Latin. So go through all of the files and just split into Latin and Cyrillic. HBS is Croatian, Bosnian, and Serbian, just an acronym for those three languages. Let's do the dedupe quickly before we continue to the next task. Let's do that. Go down below, dedupe, and run. Let's start with Serbian, or let's start with Croatian, and then run the analyze, and then get to here and see how many duplicates. I'm not sure how much time this is gonna take, but might be fun. This might take a bit longer just because it's, yeah, almost 100 million. Skipping this as it's not a language file. That's fine. Let me clear the Croatian data set here. Just delete those two files. We don't need this one. Okay. It's running. It's finding some duplicates. Will it find duplicates per dataset or like a general one? I think we should just have a single one. Let me think for a second here. So line filter. This filter should actually be global. Let's just make a global filter. Or let's see first the local filter. So this tells us how many duplicates per data set. And then after that, we're gonna do a global one just to see how many duplicates per across the whole corpus for this language direction. I think we should do it like that just to get some initial understanding. Spikes. Can we classify Latin versus Cyrillic and dedupe? Let me quickly go to LinkedIn. I'll have to move this because of DMs. Okay. Okay. Let's see what people say about transliteration. Python package for bidirectional transliteration of Cyrillic to Latin and vice versa. By default transliterates for the Serbian language. A language flag can be set in order to transliterate to and from. Transliteration is a conversion of a text from one script to another. I think the author here is Nicola. Ah, that's not the same Nicola. Okay, this guy is from my faculty actually in Belgrade. How do I install this? Posted in the Python package index. What languages are supported? Currently supports bidirectional transliteration of Bulgarian, Montenegrin, Serbian, blah blah blah. That's cool. Command line interface. Okay. Let's see the code. Serbian Cyrillic to Latin. Macedonian. Russian. Bundle them up there. And then just use them here. Main. Call on the line. We transliterate the line. Calling the to Cyrillic. To Latin. To Cyrillic. Okay, this is roughly how I expected the implementation to look like a state machine with a ton of rules and branches. And then encode. So we first grab the string. We decode UTF-8. And then at the end we encode as UTF-8. What does that function do? String decode, string encode. Fair enough. Czech Republic guy made this. Nice. Okay. But is there any way, how can we detect? What's the best way to detect? I mean, we can just add the Unicode characters for Cyrillic, and if we can use some heuristic, like if certain percentage of the letters in the sentence are Cyrillic, then we just classify it as a Cyrillic. But is there any, are there any gotchas? That's what I'm looking for. I'm just trying to understand whether there is any gotcha. Okay, search is not working for some reason here. On this piece of text, PDF, not searchable. Okay. Okay, let's just grab these letters. I guess that's how we can do it. And see what we'll end up with. That's the simplest way I know how to do this. So let's just go to mapping. We should have like what, 30? This is 30, exactly. Okay, we have the small letters and the big letters. If we just grab this dictionary, and we add it here, something like that. Okay. Huh. Well, I would never have guessed that that those are different characters. This is okay. So let's now open some file. Let's open some file that was messed up, that I remember was messed up. If we open the notes, nice. BP for word splitting, before that Moses tokenizer. So for Serbian, mix. Let's grab Tatuiba. I know that's a short one. So I'm going to grab Tatuiba. Unicode character. Okay, so let's go and grab Tatuiba. And let's grab the Serbian one. And let's see how it's going to classify. Copy the path here. Target path. Open it. Read the lines. And then do what? Let me see how this worked. They have first it's not there, then you skip. Okay, we grab tool Latin. Because this is tool Latin, let's find the Cyrillic. We grab the to Cyrillic dictionary. We decode the UTF-8. And then character by character. Okay. Might be a bit harder than I thought. We can't just naively, I mean, we can naively implement it, but let's see. The most naive, because we're just trying to do classification, not transliteration. We don't really have to be 100% correct. For now, let's just see. I don't want to waste money on OpenAI. Why would I waste money if I can just do it locally? You mean just asking ChatGPT how to do it? Sure, but it's gonna be a short. You can try and see what it gives you. Time above money, 100%. I agree. But there, I'm almost done with this, basically. So I'm just trying to see what will happen if I just decode a line. So let's just go for line in lines. Is this gonna be the same one? And then we go for character in the line. For character in the line. If C in this is found a Cyrillic one. Cyrillic counter and Latin counter. If that's it. I mean, that's as simple as it gets as the first solution. I'm sure people have gave more thought to how to do this than this, but so we just have a dictionary of Cyrillic, Serbian Cyrillic. We open the file, we read the lines, we go through the lines. For each line, we create a new counter. This is just something I want to check. I want to double check something, but it should already be the same. I'm expecting to hit this if branch, not the else branch, because the line is already inside of the textual file, which is decoded. We are not dealing with binary files, so this should be the same. And then we go through the characters and we just see, hey, if you're a Cyrillic letter, then increase this counter, otherwise increase this one, and then at the end see what's the result. Okay, let's just run this. We don't need any arguments. Run. F string single is not allowed. Not clear what you're saying. Since when does Python crash before executing? Line, decode. Of course, we crashed because string doesn't, what? Wait. We did use this before somewhere. Analyze data, we should be able to decode, right? String does have a line argument. What? Run this. Ajde probamo nešto. Ajde da probamo ne to. Okay, sh gets encoded as these two F8. I see two hex characters here. Let me just see what Google says for these characters. Code points. Sh, small sh. And this is 161. I'm just trying to understand how these symbols are This is UTF-8 in literal, and the actual code point. Does this map to this? If we, what is? Returns a single Unicode character. This is the first byte in the sequence. In UTF-8, bytes that start with 110 are used for encoding characters that are not in the ASCII range. Multi-byte sequence. This is the second byte in the sequence. Nice. That was nice description. I don't think everything is correct here though. First byte in the sequence. Bytes that start with 110 are used for encoding characters that are not in the ASCII range. I think I confused it here. It should have said the same thing. Okay. Let's now see. This is going to be a Latin one. So let's just go here. Latin sentence. Let's go until we find. Okay, let's just see. This is a Cyrillic one. So how come? Okay, I have a silly mistake in the sense that I need to split on the white lines and strip. So let's go with the line. Line equals line strip, and then that's one thing. This is more of a joke and something for me to understand how stuff works. Okay, it's already decoded. Let me see. Cyrillic count, this count. So before we start counting, what we need to do is split the line here. I want to split the line. Let me see. What's the best way to remove all of the characters? Remove all white spaces from a sentence. Yes. Well, this one will not. Or maybe it will. It actually will. This is nicer. So we're gonna do the following thing. We have the line. We just import the regex module. Just import the regex. And then go here and grab the line and convert the line. Okay, so again, what we do is first we clean from the strip. What does strip do? I think strip just removes the new line. I guess also the strip removes the white space, but at the ends and beginnings of the sentence. Python strip removes any leading or trailing white spaces. Okay, so that one, I think we can immediately do something like this for our purposes. And then try and decode. And then for character, can we write this in a more elegant way? Probably like a map and then some, let me see. We don't need to count everything, we just need to count the Cyrillic. So we can do something like this. We can literally do like list and then map and then I think something like this would work. So line, actually line should be like this. We go through the line and then if the character is in this, so we map it into the Boolean array, right? Boolean, convert it into list, and count the number of true, or just, I guess we can just sum it up. Just sum it up. And that's a more concise way of doing this. And then if this is bigger than whatever the length is minus this, then it's a Cyrillic line, right? It's a bit more elegant way to do this, and then we don't need this at all. And then we don't need to initialize as well. And this is more for my understanding of Unicode a bit better. Just curious to see some exceptions we hit with this script. That's where the learning will happen. This will work, right? Cyrillic. And then okay, let's test it again. How did we end up here? Rerun. Why is VS Code not working? I ask. Okay, 0. Nice. Let's go. Cyrillic. Nice. What was the length here? 19. What was the length of the line? 20. Why is the length of the line 20 and we get 19? Because characters. Okay, let's also remove the punctuation. In the stopes we have remove punct. I think yeah. We can just use something like punctuation and punctuation. Strip detox align. Nope, none of those matter. I know we have somewhere in the filter normalize punctuation. Might be one of these. Normalize Unicode. Not that familiar with Unicode. Have to learn a bit more there. monolingual. Text filter. Text normalizer. Unicode punctuation. It's probably going to be somewhere in here. Okay, what's the normalize? This is in the filter direction. Normalize one. Calls the normalize and then joins it. Okay, remember this is some weird combination of some weird edge cases. We don't care about that one for now. Let's go to text filter. Replace Unicode punctuation. And then remove Unicode punctuation. Yeah, I know that much. When I say I don't know, I mean mostly I don't know the details. There is a ton of details to be known here, right? A ton of edge cases, but yeah, feel free to paste there. It might help others as well, 100%. Remove Unicode punctuation. Let me see whether there is anything else. Remove Unicode punctuation. Punctuation equal to replace Unicode or remove. Replace gets and replaces them, and this grabs that Unicode punctuation and just removes it. Okay, but what we want to do is we want to remove punctuation as such, not just Unicode. Let's see what ChatGPT would do, or how do I remove all punctuation from a string in Python? We define the input string. Okay, we create a translation table. Make translation. The first two are empty strings because we want to replace each character in string with none. Okay, interesting. Let's see. From string. Okay, awesome. It's the same code. I am curious what's this. Let me see what they count as punctuation. Can I just import string or what? Apparently I can. And then just do that and then do this as well. So we make the translation and then we use the translator to translate the string. And the string is a line. And then we get a new line. Okay. Remove all white spaces. remove all punctuation. And let's try. Let's run this. Let's see what's the punctuation. I wonder, will this work for non-Unicode punctuation, as we've seen in Stopes? Replace Unicode, remove Unicode punctuation. This might mess us up, but let's see. Okay, so we have the line, we remove this, and next up we remove even the dot. Okay, and now when we do the code, if let me just think for a second. Let's assert. We need to assert maybe now that either Cyrillic count is 0 or it's equal to the full length. Otherwise, we contain both. So if this is not correct, then the line contains both scripts. Okay, I think that's good. Oops. Cool. Put the breakpoint here. And let's go. Latin. Cyrillic. Latin. Okay, let me remove this for a second. We don't need this decoding mechanism. Let's just analyze this for now. And let's also just print the progress. Mix lines. I'm gonna be adding the mix lines here. Append. And let's go. Let's just here put the breakpoint actually here. Run this to completion. See whether we ever hit this. Let's just start like this first. Print the Cyrillic sentences. Okay, here's the Cyrillic, here's the Cyrillic. Okay, here's the first one that's not. It's a mix of both. Aha. Because there are these weird dashes. Okay, let's also remove the dashes. We'll slowly be, I think we're gonna very soon start exploding this. So let's just do remove this with this. We'll probably also have to remove the underscores at one point. Let's see. Actually, let me just put some progress bar. Aha. The important thing is it's not in the Latin alphabet. Okay, let's try. Run this, see how many times we hit this. Aha, you're right. Let me see, this one might be, that's like I'm overfitting. If I see the same character, I think it's the same code, but it's not. There are some of these characters are like, what would be the good analogy? Synonyms, in the sense they look the same. Well, actually not synonyms, homonyms. They look the same, but they have different meaning, quote unquote. Let's see, versec. Unicode punctuation. Okay, let's see whether we hit it now. So this was line 61. Okay, that was definitely one of these special ones. Probably this one here. Aha. Haha, interesting. This one is messed up. You see, one of the letters I think is... This might be Cyrillic, the first one or whatnot. Let me see, 1. Okay, let's just keep on adding these. Aha. Numbers. Okay, let's remove numbers as well. I guess we can do the same logic here. Will this work? That was at 374. Yes, it did work. Aha. Kako se kaže XXX na holandskom jeziku. Okay, that's fine. YouTube. This uses a bit of English. Šta je sa tobom? This one Cyrillic letter. Not sure which one. We can analyze that later. Okay, we actually have a very decent translator, guys. When I say translator, classifier of the scripts, this actually works almost perfectly. There is only a couple of cases where there is a mix between the two scripts, and when that happens, usually one is much more prevalent than the other. As you can see. So having said that, let's now grab those mixed sentences and analyze them for a line. in lines. We can print the line first and then go through the characters. If it's there, let me see. We can append the line with the Cyrillic count and then go through the lines and the Cyrillic counts. And if the Cyrillic count is bigger than this, then we are looking for non-Cyrillic characters. Then we are looking for non-Cyrillic ones. If it's not in this, print it. Else, if it's in the Cyrillic, print it. Yeah, so basically just look at the ratio, because if there is a mix between Cyrillic and Latin, then by definition we don't know where to put this sentence, and we can just decide to put it inside of the corpus so if it has more Cyrillic letters, then we put it into the Cyrillic corpus. That's it. It's not going to be perfect, or we can filter out if the difference is, we can use that to filter the sentence. If there is too much of a mix between the two scripts, something might be wrong with the sentence itself. We did see that there is only a few of these sentences in total. So like, we can put it here. So a number of mixed lines out of the total lines is this. And then, so we go through those messed up lines, we print them, we go through the characters, and if we are talking about majority, let's maybe do it like this, mostly Cyrillic. If it's mostly Cyrillic, then we take the character, and if it's not in the Cyrillic, we want to print it. So found a non-Cyrillic character in the Cyrillic sentence, and do something like this. Otherwise, it's mostly Latin, and then if it's Cyrillic, then we say found a Cyrillic character in the Latin sentence. That's it. Let's run this. Does it make sense? Okay, so we found only 17 are messed up. Only 17 are not perfectly either Cyrillic completely or Latin completely. So let's see what are those messed up lines. So in this first one, let's just iterate. Found a Cyrillic character. So T is for some reason a Cyrillic character, and then we can do the following. Then we can just print encode as the Unicode. Let's just print C encode as UTF-8 and print that. Can we do that on the character? I'm not sure. We can see. Let's see whether this will work. It looks like it's struggling. I don't see the parser recognizing this. Let's see. It's fast to run either way. Okay. Okay, it did work. So it found a Cyrillic character. And a Cyrillic character with this particular code. T. Code points to this. Language German and English. Why is language German language? This is Cyrillic. So this is Cyrillic. From 400 through 4FF. Not all of them are. Okay, makes sense. What's up? And then we can say like UTF-8 like this. Just to better understand what went on. Delete this, delete this. That's it. One more run. We have ourselves a perfect classifier. Next up, I'm going to use this to split our data. Let me see what Maya wrote down here. For Croatian, a mixture of news and Amazon user reviews. Professional human translations into Croatian. Nice. Amazing. Okay, finally, run. So we found a Cyrillic character in the Latin sentence. And then found a non-Cyrillic letter, XXX. Found a non-Cyrillic. These are Latin. YouTube. Found a Cyrillic character. A. Interesting. So one of these characters is apparently... This is just so crazy, guys. You look at this sentence and one of them is Latin, one of them is Cyrillic, and they have different codes. You have no idea, like... Would be cool to... I don't know, would be cool to potentially map them to Cyrillic. We can fix that before, but like I don't want to push YouTube into Cyrillic. That would be weird. I just want in these cases where you have like a small a, obviously this should be Latin, not Cyrillic. But how can we cover all of the possible use like edge cases. We probably don't care because ultimately this happens so rarely that the model will not care as well. So we don't probably have to spend too much time on this, but okay, let's just kind of go through this and get some insights. Analysis like this helped me crystallize a lot of things. Just okay. If a single letter. Well, what if it was like, the thing is here you have to have semantic understanding. Because what if we had W, if W was the only one that was for some reason a typo and we had W, and then we tried and mapped that into Cyrillic. So what do you get when you map W into Cyrillic? We don't have W. So me, because I have knowledge of this world knowledge, I can understand for this particular issue, for this particular edge case, why it makes sense to map A from Cyrillic to Latin. But it's not that easy in the general case, right? That's why I'm a bit reluctant to just start mapping stuff. We could have heuristics like if a single letter in a word is from a different script, then try and map it. But even then, you might end up with some errors. Again, A found a non-Cyrillic. 0. Somebody typed in 0 instead of O. No, wait. This can't be 0 because we filtered out the digits. This is just a Latin O. K is from Cyrillic. Okay. I is obviously here by mistake. A non-Cyrillic character in the Cyrillic sentence. Okay, this is some weird, this is some edge case. So before this we just had, let me see, just double check all. Before this we had Latin, Cyrillic character T, non-Cyrillic, all this was good and clear, Cyrillic, Latin, Cyrillic, Latin, Cyrillic, and then what's this? It doesn't even have a representation. Then why does it even exist? Huh. Oh my god. The Unicode character, it's a command character, obviously, represents the left to right mark, is used in a Unicode text to indicate that the text should be displayed from left to right, even in situations where the overall text direction might be right to left, such as, for example, Arabic or whatnot. The LRM character is a control character, not typically visible. Its primary purpose is to control the directionality of a text within a mixed directional context. Nice. Well, we'll learn something today. There is just so much invisible goodness on the internet. Okay, again, J, non-Cyrillic. Okay, this one has a bit more. Okay, PDF CV. WC. And that's it. So let's think about this. Did we have any serious issues, really? We had some weird stuff that can be fixed, like this should not be D. WC like for toilet should remain as it is. PDF as well, YouTube as well. There are some of these where obviously somebody mistyped in Latin script versus Cyrillic, because people oftentimes switch between the scripts. So those errors do happen and you don't even notice the difference because they're rendered the same. We could always fix such a thing. Okay, fair enough. Let's grab a couple more data sets. Some data set that's a bit bigger than this one. This is actually fun. I like this task. Let me see. Let me think. Mixed. We tried Tatuiba. Let's try Gourmet or EU Bookshop or NLLB. One of those three. Let's try with Gourmet. Let's go with Gourmet. Gourmet, so we were Tatuiba. And now let's go to Gourmet and let's grab the Serbian script here. Copy the path. Go to analyze script. Change the path to that file. And let's rerun this. Not sure how big this dataset is. So we can kinda do something like lines length, number of lines, and then just actually we don't even want to do this. We want to just print the mixed ones. Let's go. Okay, there is a lot of sentences here. These are longer. There is a lot more here. Almost done. And well, actually not almost done. This is 50K. This was 320. Okay, a bit more. This is fun. I didn't know about those special Unicode characters that control the direction for reading. Interesting. Cyrillic table. So Cyrillic comes from 0400 to 047F. Halfway there. So what did we remove? We removed the Unicode punctuation. We mapped it into the regular one. Like this, tilde. dash. Crazy stuff. So much domain knowledge here. So replace those first. Map the Unicode punctuation, and then we remove the white space, and then we remove all the dashes and the underscores. Punctuation, digits, underscores, white spaces. What I mean by mapping Latin to Cyrillic? I mean when you have a Cyrillic sentence and then there is a Latin letter inside of that Cyrillic sentence that looks like the Cyrillic letter. In that case, we want to map it into Cyrillic. And what I mean by that is choose the different Unicode code point, because even though they are rendered the same, they have different codes. So number of lines here, oh my god, 23,000 lines out of, so like almost 10% of data here is I'm a bit back in the stream, but it's all mapped already into Unicode. So it would just filter the Unicode, which is the mapping. Latin and Cyrillic have different Unicode code points. That's the thing. Let's run this again. So here you can see found a Cyrillic character in the Latin script sentence. So one of these letters, even though it looks like it's Latin, it's actually Cyrillic, because in the background it uses this code. Let's go. Found a non-Cyrillic character in the Cyrillic sentence. Found a Cyrillic character. Which one? Ah, E. Found a non-Cyrillic character. Found a non-Cyrillic one. Here as well. Oh, this is crazy. Found a Cyrillic one. Yeah, well, this is the reason why we can't. This is a good example why we can't filter out based on the ratio between Latin and Cyrillic. Sometimes you have a legit sentence where somebody is writing in Cyrillic and then they just start mentioning these brand names in Latin. So you can't just filter based on the ratio itself. You have to, that's why it's so complex. The only thing we'll be able to do is take the ratio and roughly classify it into a Cyrillic or Latin. Everything else will be beyond the scope here. Same here. Let's see whether we find some interesting examples here. Okay, non-Cyrillic. And here we have what? Cyrillic. What's this? Dot. We didn't filter this one out. Same here. Non-Cyrillic. Large. Non-Cyrillic. Interesting, we did not filter out this one. I'm surprised we did not filter out this one. This looks like it's either punctuation or if it's Unicode, what's the thing with this one? There's gonna be a ton of small edge cases like this, I'm sure. 98, what's this one? Left single quotation mark. General punctuation. This should have been removed if it's a general punctuation. We have this punctuation here. Apparently not enough. On the Cyrillic character. Interesting. They both have what? Terry? What's Terry? You mean this? The dash? Yes. Let me just see a bit more here and we can stop. Trying to see whether there are any more insights. Can you assume in the mixed ones that even though it looks like a normal, it should be Cyrillic? I can't. That's the thing, because sometimes they use English words and there is... You would make a lot of mistakes by doing that as well. A lot of times the vocals, like these vocal letters are in Cyrillic, even though it's a Latin sentence. That's weird. That's some weirdness there. The model will learn to ignore all of this because statistically it's just insignificant. Non-Cyrillic. A lot of vocals, as I said. A lot of vocals are messed up. Non-Cyrillic. Let's see whether we find anything interesting. Something that takes my attention. Something that's an outlier. Something that looks like an outlier. It mostly looks good. No special outliers. Even among these outliers, there are no special outliers other than what we already noticed, so that's good. Yeah, all good there. It's either non-Cyrillic or it's vice versa. There are no special we could try and pick up anything that's not in Latin or Cyrillic and find some outliers like that. But yeah, there's no need to do this anymore. This is it. We can basically use this logic to decide where to place the sentence. Okay. So now let's do the job. We're going to process the dataset by passing in the root, and then for each of these, we'll find we'll leave the Cyrillic one in here and then create another direction for the Latin script. So let me create that code. Let me just think for a second. What's the best way to do here? We can remove all of this and this. Feel free to paste it in the Discord channel as well. Open NLLB channel. Yeah, it does require some understanding of the knowledge. That makes it easy for me to debug this. That's why I picked these languages first. Let me see. What I want to do is go through the lines of the target file. We already have that. Get this, and then depending on this, decide where we want to put it. That's the logic, and then this was just the analysis. Let me name this like analyze, something like that. This is going to be like experimental. Prepare line. Do all of this and return the line. Nope, prepare the line. And then take this. Okay. Split corpora into Cyrillic and Latin. Okay. So what we do here is we add like a main We import the arg parse. Okay, if this is this, then script 2 split Serbian Bosnian sentences into to separate and Latin parts. So we give it a root, and then am I safe to assume that Bosnian is using the same Cyrillic as we do? Are they the same? They should be the same. Yes. Okay. I think that's all we need. And then we just do parse, and then we call this, passing the arguments as well. We grab the root directory, and then we basically just do a walk, find the file that has Serbian Cyrillic, and I think all of them have Serbian Cyrillic. All of them should have Serbian Cyrillic. But even if they don't, we'll rename it. Yeah, this one is Serbian Latin and Serbian Cyrillic. This is already split into the Cyrillic and Latin. We can still do it. Okay. So if it's not English, we can do something like target language should be Serbian. Like this, and then we walk for root directory, files. Let's import the OS. Exactly. And then we do what? If length of files is 0, then we continue. Otherwise, assert that the length of files is always 2. And then among those, find the one with that has the suffix, the correct suffix. Find the one with the target language suffix. Not really, if target language is an infix. So if target lang in F, then we save it, and then we just extract the 0th element. Well, actually, This is 1. And then we grab the target file. Okay, so now that we have the file, now we do the processing. Now we split into Cyrillic and Latin. Let me just go grab some drink. Okay guys, I have to quickly go grab some water. I don't have any water in home, so let's just make a quick break and then we can continue. I would require a small break either way, so that's gonna be useful. Quick break, 5 minutes, buying some water. Be right back. Catch you soon, and we're continuing with the work here. Okay. See you soon, guys. Okay, I'm back. Let's continue. Let's see where we stopped here. Okay, so we're trying to split this into Cyrillic and Latin. To do that, we do the following. We open this file. Let me just see. We could have reused this. We'll see how I'm gonna refactor it later. So for now, just target path is gonna be this exactly, and then we open the lines, and then we basically keep track of Latin lines and Cyrillic lines, and not only that, but also ID lines and indices, and here Cyrillic lines and indices. Okay, so what we do is, if and only if Cyrillic Latin is bigger than this, in that case we say this is a Cyrillic sentence. Else we say this is a Latin sentence. And then we can also somehow mark the progress. Well, we can say something like here, print processing this file exactly. And then once we are done with that, hello, what's up, man? Long time no see, since yesterday. I'm working on the script to separate the text into Cyrillic and Latin, because oftentimes these languages are mixed. They have a mix of scripts. So that's what I'm doing now, and I'm just going through the Serbian dataset, and I'll be going through the files and splitting the lines into separate files, so that a single file has only either Cyrillic or Latin and not a mix of the two. So let's quickly do that. I have the lines. Now we have to do what? We have to basically do the following. Exit here, and namely we have to also put this outside of the context here, and then indent, and that's fine. So now see what's the suffix. Get the suffix of the file. Get the suffix. Target file. So target file, split on this, grab the last one. If suffix is, and then we grab the target code, target language, and if it's a Latin, in that case we have to, let me see. Just a second. What we need to do here. Can't we go from Cyrillic to Latin? We can. And that's an option. We can always do that. This is like semi-exercise. I still don't know what's the best way to do. We might be able to just convert all Serbian into just Cyrillic and train just on Cyrillic. That's an option. But then people, I don't know, let me think. We'll see what to do there. I'll have to consult some of the experts for machine translation from Serbia to see what they've done so far, what makes sense. For now, I just want to split. We can easily, once we split, we can easily transliterate a particular script, a particular file into a different script. It's gonna be easier to do that from Cyrillic to Latin than vice versa, because you don't want to transliterate YouTube into Cyrillic YouTube, if that makes sense. Okay. So now the issue here is, let me see. Yeah, I think I know what I want to do. I want to create 2 new files. I just want to create 2 new files, okay? And that's it. And then we're gonna later fix the merging and everything else. So I want to do target path Latin is gonna be the same as the target path, but we replace target lang with this. No, wait. So target file, target path. We want to do root directory. Root directory with target lang Latin. That's all. That's all we need here. And then target path Cyrillic. We want to have same lang, because it's gonna be, we're gonna assert that this is the 3-letter code. Exactly. And now that that's a constant, always 3 letters, this will be good. And now we just open the files, and now we go through 4 file path lines and indices. No, not Cyrillic, just lines and indices in this. We open the file path. But we also have to do the same for English. We can't mess this up. We can't mess this up. Awesome, man. See you soon. So we open it up. We don't write the lines and the indices. We just write the line. So read the lines, prepare the line. Aha, no, this is going to be process line. Process line is we're gonna iterate through the process line. We get this, and then this, and then when we add the original line. That's fine. That's fine. So we process the line, and we iterate through that line to see how many Cyrillic characters we have. If that's bigger than the length minus the Cyrillic count, then we append it here. Otherwise, we append it to the Latin script. Okay, this makes sense. But we have to do this in parallel for English. Why, man? Spend weeks doing my file management for a project. For months. Why? Why so long? I'm just thinking what's the best way to do this, because we have the English file as well. Let's now grab the English file. We need to read. We need to grab the English sentences as well. That's the thing now. So we have to go grab. We have to go grab the files. Makes sense. Okay, temporary target, and we do the same thing for temporary source. Let's do the same for the source, but for source we assume that the source length is just English. English is the source. And then we assert that this is one. Target file, and we grab the source file. Maybe it makes more sense to do it like this. And then source path. Source path. And now we want to open up this. So now that we have exact lines here, we open the source path. We read the lines. We go through the lines. Come on, Copilot, come on, I know you can do this. Help me out. I don't want to type everything. Just lines, and then... No, we don't prepare here. In this case, we just have to find where this index belongs to. Okay, do you guys get what I'm doing? I'm just trying to now separate English into those that are paired with Latin and Cyrillic. Let me just do that quickly. So we need the indices from the above, from here. So we can insert the index. Yes, but we need to find it. What I'm gonna do is we can store. The easiest way to do it is to just ask what's the index, and to grab that particular. Okay, I think the best thing to do is depending on the index, if the index is there, we store it here. Okay, yeah, I think we just need we don't even need an index. We can just store the lines here. I want to have some way of making sure we don't make a mistake, but we don't need index here when splitting. But we need, okay, let me do like this. Latin indices. Try and write it down. It's gonna be easier. I can't follow the stream of text like that. It's hard. Cyrillic indices. I'm gonna do like this, and then just add the I here, and store the line here as well, and Cyrillic indices as well. And then here, if I is in the Latin, that means we have to add this sentence to, no, not Latin lines. This is because we need new ones. We now need These are going to be renamed to target Latin lines and sentences, and these are target Cyrillic lines. And these are okay. And then we just need the same thing here. We need the source paired with Latin lines, and we need the source paired with Cyrillic lines. And so if it's in the Latin indices, then we say append the line and the index. Otherwise, if this, then do this. Otherwise, raise a value error. Raise a value error. Okay, and by doing that, we now have split the English text as well, and we additionally have the index, so we can compare. We can make sure that when we are iterating, there is no discrepancy. So there is some redundancy I've added deliberately. So I've added a deliberate redundancy so we can do some checking. So let's see what we do now. So we open the file path we're writing. We go through these. And we will also need, oh my God, this is just so simple. This is so simple. It's just, I hate this mumbo jumbo. You just have to be very careful. That's all. Like, I now need the output file for English coupled with Latin. So I'll do it like this. Source. I'm just gonna stop using source and stuff. So source coupled with Latin out path is gonna be this, and then English Latin whatever. I'm just gonna do something quickly that works, and then I'm gonna think later. Coupled with Cyrillic out path, and then just join it like this. And then later I'm gonna process that. So now we open up the first one, target path, and then we need a coupled with Latin one, and we also need to do the same thing and then coupled with Latin as well. Output path like this, and then we need to open both of these, this like this, and then with open the second English file path, English. So with open English file path as English. Oops, guys, my camera just died. My battery exhausted. Let me just change it quickly.